Alright, here's the answer key for the semester 2 review. Now, I don't know why all the questions are blurred out. It probably has something to do with how the digital file transferred over, but nevertheless, to do the first one, you have to set it up as the limit as n approaches infinity of the sum of I equals 1 up to n. 1 up to n of, and now let's see, it'll be f of I over n, all times 1 over n, like that. So if I plug in I over n into the function, I should get, I squared over n squared, plus 2 all times 1 over n. So if I distribute that through, I'd get the sum of I squared over n to the third plus 2 over n. Okay, so that would mean the sum of I squared is n times n plus 1 times 2n plus 1 all over 6, and I still have an n to the third there, n to the third, plus 2 over n times n itself, so those will cancel. This n cancels one of those, so that's now an n squared. Alright, let's see what else we have. I should probably multiply that out, so I'll get 2n squared plus 3n plus 1 all over 6n squared, and then I still have the plus 2 over there. Okay, now through the limit process, if I separated out these three fractions here, that one, and that one, this one goes away and that one goes away, so I should just be left with 2 over n squared over 6n squared plus 2. This simplifies down to 1/3 plus 2, so I should end up with 2 1/3. Okay, now let's go to the other ones. Now these are just the indefinite integrals here. So simple power rule says that 3x squared, change it to 3 cubed, or 3x to the third over 3 plus x squared over 2 minus 2x plus c. So simplifying just a little bit, it should just end up with x cubed plus x squared over 2 minus 2x plus c. Okay. Then number 3, put the 1/2 out in front of the integral and say that this is x to the negative 1/2. Okay, add 1 to the power and then divide by the power, so you have 1/2 x to the positive 1/2 divided by 1/2. Well, if I have a half divided by a half, those will cancel, plus c, so I should be left with the square root of x plus c. Number 4, again, kind of is still this, we're still on those kind of those basic power rules. So 4x to the second all over 2 minus 3 sine of x. The integral of sine of x is negative cosine of x, so it would be negative 3 cosine of x. Let's change to plus c, so then I end up with 2x squared plus 3 cosine of x plus c. And the last one on this first page should be, this one's things get a little bit more difficult because I have something multiplied together. I have an x cubed being multiplied with this over here. So what I need to do is I have to do a u substitution. So let's let u equal the inside of the radical. Usually let it be the most complicated part. So that means du is equal to 4x to the third. Okay, dx. Well, I have all of this. I'm just missing the 1/4 out in front. So I'll put it out in front like that. So then I have a 1/4 the integral of the square root of u du. Okay, well the integral of the square root of u is just 1/2 u. So we have 1/4 and then times u to the 3 halves over 3 halves plus c. Flip that fraction over, becomes a 2/3. Cancel that, and so then this 2 cancels that. So you should end up with a 1/6. And then instead of u, we will put in x to the 4th plus 2, all to the 3 halves power plus c. Okay, number 6. Again, looks more like a power rule to me. Or not power rule, a u substitution. So let's see. I'm going to let u equal the tangent of x. And here's why. Because I know that the derivative of tangent is secant squared of x, which I have that very thing right there. So then that means that I just have the integral of u to the 4th du. U to the 4th is, change that to u to the 5th over 5 plus c. So that means I have 1/5 tangent to the 5th x plus c. Okay, let's look at number 7 here. And we have, let's see, we'll write this as a definite integral from 1 to 2. I have 1 over x squared dx. Okay, bring the power up to the top. So you have x to the -2nd dx. So the integral of that. So add 1 to the power, so it's x to the -1st over -1. And we will evaluate this from 1 to 2. So let me just write this out. So it's -1 over x, and then it's 1 to 2. So that should be -1 over 2 minus -1 over 1. That changes to a plus. So -1/2 plus 1 is +1/2. Okay, let's look at number 8. Sorry. Number 8, let's see, we have the definite integral. Okay, kind of a simple power rule again. So we have -3v to the 2nd over 2 plus 4v. And we will go from 2 to 5. So if I plug in a 5, I will end up with -3 times 25 all over 2 plus 20 minus -3 times 4 all over 2 and plus 8. Okay, need to make sure I put that all in parentheses. Alright, so let's see. It looks like here I've got -75 halves plus 20 minus, let's see, -3 times 4 is -12, so that's -6 plus 8 it is, so that'd be +2, like that. Alright, so I'm going to subtract 2 from 20, I get 18, so -75 halves plus 18, and let's see, change this to base 2 there, and that would be a 36. So let's see, that should come out to be, let's see, what, -39 halves, right? Which is equal to -19.5, right? Okay, and let's go to number 9. Okay, so kind of one way to do this, I'm going to kind of do the shortcut method on it. I see that everything has an even power. That's to the 2nd, that's to the 0 power of t. So I'm going to change the interval. Instead of going from -2 to 2, I'm just going to say, I'm going to go from, I'm going to go from 0 to +2 because I know it's an even function, and then I'm just going to double it because it's symmetrical about the y-axis, t squared minus 2. Alright, power rule says, add 1 to the power, so it's t to the 3rd over 3 minus 2t, and we will go from 0 to 2. Alright, 2 to the 3rd is 8 over 3 minus 4, like that. Change that to base 3, so it's a 12. So then I should end up with, wait a minute, did I do that right? hold on. Yep, no, I did it right, excuse me. So, but I did forget to double it. So here I would end up with, on the inside I would end up with negative 4/3, but then I have to double it, so then I do get negative 8/3. Whoops. All right, and then we'll head to number 10, like this. Okay, so I do have two things multiplied together, but I can just multiply that x to the 1/2, or the x to the 1/2 through, so I should end up with the integral of, let's see, from 0 to 1 of x to the 1/2 minus x to the 3/2 dx. Okay, add 1 to the powers. I should end up with x to the 3/2 over 3/2 minus x to the 5/2 over 5/2. Flip the fractions over. 2/3 x to the 3/2 minus 2/5 x to the 5/2, and we go from 0 to 1. Okay, if I plug in a 1 there, I should just get 2/3 minus 2/5, all minus 0 when I plug the zeros in, no big deal. Okay, so common denominator would be 15, so I'll just cross multiply. So I should end up with 10 minus 6 all over 15. So should come out to be 4/15.